Welcome to C4E in Nairobi, Kenya. We aim to make landscapes more resilient for people and nature by providing evidence-based solutions to some of the world's most pressing challenges. We harness the multiple benefits trees provide for agriculture, livelihoods, resilience, and the future of our planet. Today, we'll take you on a tour of some of our labs to show you how our scientists are helping to restore ecosystem functions to improve food security and livelihoods in Africa. And what have we got here? Soil. Meet Dr. Leanne Winowiki, who heads our soil research at C4E. Lee, why is soil so important?
Healthy soil is the foundation for building sustainable food systems. It provides more services than any other substance on land. Soil is also incredibly diverse. However, we often do not acknowledge this diversity in how we manage our soils. At C4E, we have pioneered a rapid, accurate, and cost-efficient technology to assess the diversity of soil properties using light. Soil spectroscopy has enabled scientists, land managers, and farmers to better understand our soils across landscapes. In addition, we are able to create modern soil maps that reflect the spatial pattern of soil functional properties that are key for informing and prioritizing sustainable soil and agricultural management.
And now from the Soil Lab, we come to the African Orphan Crops Consortium Laboratory. Here we meet Dr. Prasad Hendra, the lab manager. Prasad, can you tell us why this lab is very important for food security in Africa?
Malnutrition is a widespread phenomenon across African nations that can be addressed by diversifying African food systems through an array of nutritious non-mainstream local crops. To support this, the African Orphan Crops Consortium, or the AOCC, is using DNA-enabled method to improve production of the non-mainstream orphan crops. These orphan crops are orphan because they are neglected by the mainstream scientific community, they are under-researched, underfunded, but they are inherently rich in nutrition, they are locally adopted and culturally aligned. Biologies of many of these orphan crops are also difficult to handle, which can be then tackled by also using the DNA-based methods. Here, what you see is the next generation DNA sequencer that can sequence 300 human genomes in a span of 7 days. The DNA sequences made by this machine for all the 101 African orphan crops can further be used to study different traits and associate these traits such as drought tolerance, disease tolerance, pest tolerance, and which can be then used to make these already nutritious crops high yielding and adapted to the changing climate scenario.
And now we meet Dr. Susan Chomba, who heads our EU-funded Regreening Africa project that aims to restore 1 million hectares of degraded land across 8 countries. Susan, why must we invest in land restoration in Africa?
We must invest in land restoration in Africa because the problem is massive. Approximately 65% of agricultural land in Africa is degraded. This undermines the potential for that land to be able to produce enough food for its people. It also undermines the ability of the governments in the African countries to be able to meet the goals of food and nutritional security. Therefore, investing in land restoration is a priority because it not only provides enough food for the people, but also it provides other benefits such as carbon sequestration, hydrological cycles, as well as multiple biodiversity functions. When we make landscapes resilient for people and nature, there will be less hunger. We must invest in food systems to make this happen.